Our next paper is covering the APEX program with Kelles and Radha. Gordge is a mechanical engineer who has embraced XR, I love this one, as a tool to enhance engineering and drive innovation. And Radha, who I've spent a lot of time with in a few programs now, is in the electrical and mechanical engineering design group, and she's gotten involved in augmented and virtual reality and is part of the team developing APEX. Join me in welcoming them.
Hopefully we've got that right this time. You have to push it. You have to push the button once. Okay. Well, while we're at it. Hey, everybody. It's good to see everybody here. It's great to see some people who are so excited about this field. Thanks to the XRCC team for putting this on. You guys rock. It's great to see some R1Hers here represent. But what I see when I look around this room is a room full of people who are excited about XR, or at least you're enthusiasts, people who are willing to embrace a new technology. How many of you are, how many developers do we have? You've done something in Unity or Unreal. It didn't have to work, it didn't have to be good, but you've tried it once? Okay. How many people have ever been excited to put on a headset? Okay, yeah, that's more like it. Well, I'm here to talk about the other people. I want to talk about the people who aren't in this field, the ones who are the non-enthusiasts, but the people who could really benefit from it too. I want to talk about the people like the engineers here who maybe have never put on a headset. And I want to talk about how they could benefit from this technology too, and what we're doing to engage them. Hey. Okay, I'm Gordge. I'm a mechanical engineer. And I fell in love with XR when I learned that I could take these assemblies I built on my CAD programs on a just 2D computer screen using 3D software. And now I could put that in a headset and bring it to life.
And I'm Radha Deshumukh. I am like Kelles, a mechanical engineer. And I too had no idea about the power of XR until Kelles and her team put me in one and showed me what I can do.
We're both engineers in the concept design and realization branch here. In our group, we do it all. We do mechanical and electrical engineering. We span the entire design process from early design to fabrication, assembly, test, and analysis. You name it, we build it. The tools we use every day are also 3D. We use things like Creo and SolidWorks in order to do detailed design. This is how we build things like the Parker Solar Probe, like DART. And a lot of you all here use different sort of 3D tools. You use Unity and Unreal and game engines like that. It's a different sort of 3D. And often these two groups don't cross paths too often, but there is a chance for overlap here. How can we make tools that allow the engineers and the other users who live in the world of 3D, how do we transform the way that they work? There we go. We do best when we solve 3D problems in 3D spaces. So engineers should love XR. But adoption has been slow, or at least mild. What's stopping us? So I'm here to talk about adoption in the design engineering world. Where we're at right now. When I first started at the lab, I had no idea about virtual reality. I had never heard the term XR, that's for sure. But within the first couple years, I learned about a tool called Protospace. It was awesome, because now I could take the assemblies that I'd built, and I could walk in them. I could see them come to life around me. That was amazing. And yeah, I mean, it was with a HoloLens 1 at the time, so I could only see this much come to life around me, but that was still cool. Since then, we've been using it for the past, at least 6 years I've been using it. And it's amazing because you can put on a headset and see your designs. It's collaborative. We can see the same thing. We can take it on the road and show the same thing to an executive that we could to a small child, because everybody can put on a headset and understand if you show them something intuitive in a 3D space. But conversely, it's also a little limited. It's been an amazing tool, but we can only use it on the HoloLens right now. Also, the interactions and functionality are a little limited. There's not really, you can move models, you can rotate, you can section view, and that's cool. But in order to make it an actual design tool, engineers need more. That's why we're developing Apex, the APL engineering experience. This is our collaborative, real-time, multi-user engineering tool set. It's under active development here at APL, and we're designing it to fit our needs, to fit into our existing ecosystem, to use the 3D tools that we use. It's multi-user. Somebody in building 201 here could put on the headset and be in the same session as somebody on the other side of main campus. Also, somebody on the other side of the country. We're building in tools that go beyond just viewing. We want to be able to sketch and mark up. Not only that, but closing the loop. Now you can take these annotations and bring them back into our CAD software. It helps you get a better spatial understanding when you can measure things, when you can make them transparent, when you can take an assembly apart. And when you do that, you can capture it. You can take screenshots and document. And because we're building it in-house, we have more control over security. So now we can handle CUI data. And we aspire to handle higher levels than that, too. My favorite part is that it's multi-platform. Right now, we can use virtual reality. You can put on a Quest headset. And now you can design in a very neutral space. You have a 3D avatar. You can fly around and use all of those features there. We also have a desktop client, which is a great way for somebody who doesn't have a headset to view the work that you're doing and participate, even if they don't have the hardware. But the part I'm excited about as a mechanical engineer is the augmented reality part, and that's what we've been adding over this past year. Some of you have heard us talk about Apex before, but for an engineer like me, these are the things I'm really excited about. Being able to take this like a model and put it in the context of the environment is an amazing tool. What does this assembly look like when it's on a table? Can the technician actually fit their hand or the hex key in this space? This sort of context is what gives like a technical edge to these tools. Like I said before, Protospace has been great. It's the right tool for the right thing at the right time. We can easily take a CAD model and bring it into the headset and show somebody else. But right now, you can really only move it around. You can rotate, you can section view. With Apex, we're trying to enhance that engineering process. We need to be able to add technical design. That's why we need to annotate. We need to bring it into our existing tools. But like I said before, it's still under development. And as we are building this tool, we keep asking ourselves, what does it take to get this in the hands of engineers? Through a variety of personal anecdotes and things we've seen while developing this and things I've heard from others, there are a handful of really, really big things. A headset can be intimidating for people to put on. We've got a lot of enthusiasts here. Most people here have put on a headset. But I can't tell you the number of times I've been in a HoloLens and going like this, and people are like, what is she doing right now? She's just poking at the air. People can feel silly. That can be intimidating to put on a headset. But that's why you need to wow them the first time. Things need to work, they need to work correctly, and you need to have the tools they need up front. Also, even just getting a headset in the first place can be hard, but that's why we have a fleet of them at Central Spark that APLers can check out. And we know across the lab that security requirements vary. It's hard to design a tool that works the best for everyone in every use case. So, throughout this process, that's why we've been trying to design alongside our users. And Radha's going to talk to you about how we've been able to use this tool for actual projects at the lab, using it to do the engineering that we need.
Okay, so spoiler alert, I'm one of the users. As a mechanical engineer or any design engineer, we tend to follow this kind of pretty serialized pipeline where you have an idea, you put it in CAD, and then you go through a series of steps to prototype it on a printer or acrylic or cardboard, and you do mock-ups and fit checks and manufacturing, and then you keep doing that until you get a final product. And this works. This is a process that I use and hundreds and millions of engineers use. But a result of this is sometimes there's downtime. You know, someone has put a 4-day print on a printer and you need a part just to see what it looks like. Someone is just waiting to approve your drawing, but you need to know, okay, is this going to fit in my space? The manufacturing shop is slammed because they're launching a spacecraft in like 2 weeks. So there's a lot of time that needs to be filled, and time is money. But with VR, we can fill in those gaps in really cool ways. So now with augmented reality, I can do fit checks and clearance checks with real tools and real parts. I can do scale viewing of models that I'm designing, that Kelles is designing, that are being designed in California, being designed across the world, and I don't even need those parts in my hand. I can just download them. That's huge. I can do mock-up overlays and manufacturing overlays with parts that I just have lying around, or parts that I've gotten from the shop already, and augment them with augmented reality. I'm a mechanical engineer. My desk is absolutely covered with sheet metal and acrylic and 3D parts and screws and headsets and VR software. We're not trying to replace the pipeline at all. We're trying to actively enhance and augment it so design engineers are able to constantly and actively develop their designs in a way that's really immersive and really cool to get to their final product. Okay, so this is a really cool example we actually just did a few weeks ago where some engineers in R1H came to us, and this is a small part of IMAP. It's much bigger than this. And they had to push out a design, and they had an issue where the technicians didn't know if that design would work because they had to put their hand in it. And you can't put your hand in Creo. I tried. It doesn't work. But you can put your hand in an augmented reality model, and this is huge. I mean, this is a multi-million-dollar spacecraft. So what we did was we just took some headsets over, put this up on the put this up in augmented reality. The technicians had their tools and their part that they wanted to assemble. And within 10 minutes, no prototyping involved, no manufacturing, no drawings, no nothing. They were able to come to a definitive design decision and decide, okay, we can do this, let's push the design ahead, and that saved a lot of time and money. And we actually ended up using Protospace for this, but because this is so powerful, we want to augment the things Protospace already gives us with tools that Apex is developing and building for us to use. Another use case we have is, if we're moving now to the Apex environment, is scaling. As engineers, we really, really, really need to understand the scale of the parts we're working with. I would say every single engineer that I've taken into a VR environment, the first thing they say is, oh wow, this is way bigger than I thought it would be. Kelles mentioned it, we work in 3D. We need to understand the scale of what we're working with. And that's why VR is such a powerful and cool tool, because not only do we get the scale of, what do I look like next to this? What does this look like next to a smaller model? This is Starlink next to a smaller CubeSat that some R1Hers have worked on. We can annotate, we can measure, we can move around the model itself. Unless you have like a jetpack, I don't know how you're going to get to the very top of a Starlink satellite or Europa Clipper. But with VR, you can just do it. You can see parts of the model that aren't readily accessible to you if it was in front of you in real life. You can have that multi-user experience. Again, we can do this with people who are developing across the world if we really wanted to. And just having that sense of scale is huge. So this is actually one of my favorite examples, because this is how I first got involved with VR. In addition to all of the other random things I do at APL, I'm also a routing and harnessing engineer, which means it's my job to take a spacecraft or a pod and route the cables and network paths within it. Routing is hard. It's not intuitive. The Creo cabling software is difficult to use. I don't want to harp on about it because that would be another talk, but networking and routing are hard, and you need a critical understanding of space. And that's why VR is so powerful, because now I can just load up my CubeSat into VR, look at it and say, okay, I drew this cable on here. That's not going to work. It's running into a radio box. but I can route it around this leg. And that I can then re-import back into Creo and use that to influence my routing designs and routing models. And that is a huge time save. And engineers and technicians in space do actively use VR and AR when they're doing their cable builds right now, which is not something that was really even thought possible until very recently. So this is another really good example of how VR can affect a part of your work in your life that I had absolutely no idea this would even work when I started doing my job as a harnessing engineer.
And like from the developer perspective, working alongside Radha on this process really showed us that this is one of the features we needed to implement early. Being able to paint in 3D, we can do that. But then closing the loop and bringing the wire routing that she's drawn back into our software so she can do something with that, that's the important part. And that's why we doubled down on that feature early.
Okay, and now we want to bring it full circle. You've been in a VR session for like 30 minutes with someone. How do we bring that back to Creo or SolidWorks or what have you? How do you take this design input and turn it into something tangible? So what we've actually done is we've created a pipeline where I drew this beautiful blue box. I worked very hard on it. But now I can take my beautiful blue box that was just a sketch and actually turn it into a Creo part. And then I can use that Creo part to design something. This is not an electronics package. This is not what an electronics package will look like. But it's an example of now I know here's the general size and shape and scale of what I need to put on, for example, Starlink's platform. We don't have Starlink sitting around at APL. We probably never will. But with VR, I don't really need it. I can just load that into my space, and then I can put my packages in my spacecraft, in my satellite, in whatever model I want to. And the whole process doesn't really take that long. Well, for me, now it takes less than an hour. Whereas how long would it take to get a 3D printed mock-up of an entire satellite? Probably days, maybe even weeks. So now this is just another example of here's how we can take VR, a virtual environment, and turn it into something that will one day be a tangible package. This, again, is huge. So what's the vision? Why should you, as a neuroscientist, an electrical engineer, a material scientist, a mechanical engineer, why should you care about this?
And how do we give the amazing engineers that we work with every day the tools that they need to do their jobs? Not only that, but to do them in an amazing and innovative way.
With Apex. So Apex it's pretty simple. It reduces prototyping costs. Again, we want to use this to augment traditional prototyping, but it can reduce the time that's spent between waiting for prints. It reduces idle time. I don't have to wait for someone to check their drawing into Windchill or check their part into Windchill or PDM. I can just quickly load it up in space, see what it looks like, and be done. It creates an immersive design experience where you understand, here's the scale of what I'm working with. An M3 screw is a lot smaller than you might think it is. But with VR, now I know that. I could have also just gone and looked at a screw, but now you can do both. And you can just use VR as another rapid design prototyping tool. We want it to be kind of used in the same sentence as, well, we could 3D print this, we could make it out of cardboard, or we could view it in VR or AR. And all of that brings you to a tool that's not only designed for engineers like you, but built alongside engineers like you. Any one person in this room could come to us and say, I have a project, and I have this need for this project. Can you help me implement this into Apex's software?
I believe so strongly that XR can enhance the way we do engineering. It's not replacing any of our typical processes. We have amazing tools like Creo and SolidWorks that help with that technical side, and they're good at what they do. But I think that we can augment, pun intended, I think we can augment these processes and make them better. How do we give that engineer, how do we give her the tools that she needs? Right now, we have the means to easily create a multi-person viewing experience. But I have personally seen that adoption can be slow. A lot of people, they don't feel like they can do it, or they find the headsets intimidating or silly. How do we bring these to the people who aren't the XR enthusiasts? I want you all to remember the next time you're developing your application, and I think you know this, but just take it to heart. They don't always view XR the way that we do. We do best when we solve 3D problems in 3D spaces, and XR can enhance that. User feedback, working alongside our users, like Radha, is driving the way that we develop this tool. And the next time you're developing your application, how can working alongside your users drive your development? Could you bring them in at a different time? Could you work alongside them? Maybe bring them into the development side a little more so they understand not just the what, but the how, and then we can understand their needs. And also, this is just the beginning. In that table I showed you earlier, our branch does it all. We build, analyze, test. We're electrical, mechanical. We do hardware and circuit boards. We do everything. Well, a lot of stuff. You name it, we build it. So there's a lot that this tool could still be used for. We're looking for more use cases. Maybe we want to use it to show thermal results or structural simulations. So if you have some ideas, and if this is something you want to try out, we can help with that. Come talk to us. I could talk about this stuff all day. It's something I'm so excited about, and we really want to share it with other people. So if you think this is something you want to try, come talk to me or Blake. Everybody knows Blake. And also, if you want to try importing a model, you can talk to my coworkers, Radha and Sam. They went from no XR experience, like what, a year ago?
Like 6 months ago at this point.
Yeah, to being able to import models and view them on their own. And if you want to try Apex out, come to our demo. It's in
38 minutes.
There you go. So we're excited to show you. And I'm hoping you can come check it out. Thank you very much.
Do we have questions for Kelles and Radha?
Great. Okay.
Well, no. You're not getting away. Yes. Could you come up to the microphone, please? Oh, sure.
Yeah, sorry, I came in late, so apologies if you answered this, but I was wondering if you had like a number of surfaces or a polygon count that were limitations and what headsets you've used with this so far. And if your compute's being handled by a PC or onboard.
Blake looks so excited to answer that question.
Yeah.
I hate to deprive him of that.
Thank you. So for part of the whole reason of our design, one of the things is we're being underserved by industry because they kept wanting, like, startups kept promising us this kind of capability and then insisting on putting it on their cloud, which was a non-starter for security reasons. So we do the processing on a local PC that runs APL's security stack. So we don't run it on device, we run it on a PC that is nearby that has all of the encryption and safety protocols that is required for APL to do work. That's also what lets us believe that when there's a project that has an interest to do this at a higher level of classification, that we will be able to do that because we should be able to bring the software into a classified environment and run it. So then really it depends on the PC that you're running. We have run, I don't know, do we have Europa Clipper handy? I don't know. It is a very large model. It's one of those models where you put it on and you're like, oh, I didn't even know spacecraft could be that big. So our polygon counts are pretty high on some of the laptops that have pretty high grade GPUs.
I was wondering, this is a difficult question, but how do you decide, how do you justify the cost, or how much do you think it would cost to develop this application? Because I just think about what's out there in the marketplace, and there are a couple of products that are very similar to this that you could get for, 50 grand a year. So I'm just wondering how you compare that with what your development costs would be to make it.
I'm going to start it and then I'll let you. Yeah, that's a great question. I mean, since the very beginning, when we proposed this project, that was top of our mind, right? You don't want to reinvent the wheel. You don't want to do something that's already out there. But, in time and time again, we've seen that there are specific things that we need to make sure our engineers can access. Does it fit into our processes? And that sort of stuff, that's a trade-off. And that factors in when we're deciding just how many resources we want to put into this. And I think Blake has something to add.
Yeah, I mean, we started with Protospace, right? And that was software that we licensed from JPL. JPL over time wasn't maintaining it as much, and we had features we needed. And Microsoft promised stuff and didn't deliver on it. And then we've seen startups they would promise us stuff. We literally licensed software from one startup and things were going great. And then they decided that NFTs were really shiny and they were going to go do NFTs now. But we're still building spacecraft. Like, we can't just stop using it. So we said, this isn't that hard. We did not believe it was that hard. Oh, and we wanted to be very aware of vendor lock-in, because there have been a lot of people that want to lock us into their specific headsets, which that doesn't scale at APL. We have different teams using different tools and different technologies. So we finally said, this doesn't seem that hard. So on the ITSD side, we've invested about $100,000. And then we've gone and had various research that we have done in various sectors and departments. So the AI stuff that was part of my presentation was actually, that is part of this tool on an experimental branch. So we are continuing to grow it and develop it. But long term, we think it's going to be good and valuable, but we are underserved by the industry. Nobody really, we start talking about GovCloud and GCC High and stuff like that, and most people's eyes glaze over. They have no idea what we're talking about, and so we can't use those products. So we needed to serve ourselves.